Okay, so we will start with today's session. So in today's session, we will talk about basic data basic, and then we will talk about some descriptive statistics, not inferential statistics. We will talk about how we look at a single variable, relationship between two variables, and then we were trying to use these concepts in using our software. Okay, so let's move on. So we were talking about data basics, and we were talking about observations, we were talking about variables, and what kind of data types they are. And we will explore how to summarize our data, and we're trying to see the relationship between variables. So we will start looking at this kind of data. Okay, so there are a lot of data types out there, but in medical analysis, medical research, the kind of data type we are commonly using is data metrics. I think everybody has already used this. It is something like a spreadsheet program. So it is called a data matrix, and it has rows and it has columns. Okay, so in R we call row as observations, and we call column as variables. So I think people are already familiar with Microsoft Excel. In Excel, this is very similar to Excel. In Excel, we have rows and we have columns. Okay, so R also has the same concept. We use row as observation, and we use columns as variables. Okay, so from now on, I will use the terms variables, observations, rows, columns interchangeably. And they are the same. Okay, so we are talking about variables. When we try to think about data collection process and what kind of data are we going to collect, we usually talk about in terms of variables. Okay, so generally we talk about variables in two groups. First group is numerical, and the second group is we call categorical. I think a lot of people are already familiar with this. So for numerical, sometimes we use the term quantitative. Sometimes for categorical, we use qualitative. But it is somewhat confusing, right? Because in research, we also have quantitative methods and qualitative methods, which is quite different in this case. Okay, so that's why we will use numerical versus categorical. Okay, so what is a numerical variables? And numerical variables take on numerical values. So these values make sense. They are sensible to arithmetic operations like adding, subtracting, multiplication, and averaging. So if you have a numerical variable, you can take these values and then you can add them. It makes sense, and you can do arithmetic operations on them. So that is a numerical variable. Okay, we will talk example of these variable types. And the other type is categorical. So they take on the limited number or distinct categories. So you already know this, like gender, we have male, female, or even transgender if you put it in that category. Say like religion, these are also category. So these are often, so remember here, one point I would like to make here is that they are often identified with numbers, but these numbers just represent these categories. They do not make sense to conduct arithmetic operations. So these are the difference between numerical and categorical, very broadly speaking. And then we will subdivide it into subdivide numerical variable into two types, continuous and discrete. But I think at some point this is not for generally speaking, it's not that important when we consider about the statistical test later on. But numerical variable has two types, continuous or discrete. And categorical variable has also two types, two subtypes, nominal and ordinal. So let's see what are the difference. So continuous variable, they contain decimal points, example like height. Okay, so 180 centimeter or 180.5 centimeter, or we can say 180.55555 centimeter. And it still makes sense because these values, so they are called continuous variable. They can contain decimal points and it makes sense. And on the other hand, on discrete variable, these are like the number of children you have, okay? The number of siblings you have, the number of patients you have in a clinic day. So you cannot say, today I have 10.5 patients. No, it doesn't make sense, okay? So absolute number, integers are called discrete. But even if you cannot remember the terminology, just consider if there is any decimal point and it makes sense, then it is continuous. If it is absolute value, if it contains any decimal point and it doesn't make sense, then it is called discrete variable. Okay, so these are numerical variables. For categorical variables, the only thing you should consider is the order. So whether these, if I order the variable from A to Z or from lowest to highest, does it make sense? If it makes sense, then it can be ordered, so it's called ordinal. Okay, and there is no sensible order, then it is called nominal. So we will talk about this with more example. So this is a data set from Google's transparency report, and these are the list of country. So each row represent one country. So one row represent one country, and then this country requests the transparency report. And how? Let's see. Okay. So country, name of the country. Okay, these are tags. So let's consider about it. These are not numerical value. So they must be categorical variable. And then is it nominal or is it ordinal? So does it make sense if we order from A to Z, or does it make sense if we just leave it as it is? Okay, so anyway, we can just leave it as it is. There is no sensible order for a country. Okay, so that means that the country variable is nominal variable. Next variable is this one, CR_REQ. This is the number of content removal requests made to Google. So country, so these country requests to the Google to remove certain contents. Okay, so this is content number 1, content number 2, content number 3. So these should be integer, absolute number. So this means that it is discrete numerical variable. Next, we have CR compliant. So the percentage of, so how much Google remove the requested contents. So in that case, there is a percentage. So as you can see that in the data, there is no decimal point. But if you consider that it's a percentage, then something like 40.5% makes sense. So it is continuous numerical variable. But if you look at the data, there is no decimal point here. So anyway, the next variable is UD_rec IQ. So that is the number of user data requests as part of a criminal investigation. So this is also the number of user data requests. So what kind of variable do you think it will be? Anyone?
Discrete. It's a discrete.
Okay, so everyone agree? This is discrete continuous variable. Sorry, discrete numerical variable. So the next one is the UD compliant. So this is the percentage of user data requests Google complying with. So again, we have percentage. So this is continuous numerical variable. So it's like when we design a study, or even when you read a paper and trying to think about the variable presented in that paper, you think in that sense, okay? Whether it is numerical or it is categorical, can we subdivide it? Does it make sense to order, or does it make sense to make arithmetic operations? Based on that, we can change the type of the variable. So why are we talking about this? Because later on, when we talk about the statistical tests, or when we talk about the advanced methods or other statistics, this is really, you know, everything based on this data type. Based on this, whether you do a certain test or whether you do a certain modeling technique, everything depends on the data type you collect or use describe. Okay, so next is hemisphere. So this is the hemisphere that the country is located in, southern or western. So obviously this is not numerical, okay? And there is, as far as we can see, there are two categories, right? Southern and northern. So there must be something limited number of category. So obviously it is categorical. And can we order them? Does it make sense to order them? No, it should be fine, right? Whether the northern category come first or the southern category come first, it is okay. So it is nominal data. And HDI, which is a Human Development Index indicator, which indicate very high, high, medium, low. So as you can see that there is a flow, right? You can come from highest to lowest, or either from lowest to highest, low, medium, high, very high. So this means that this is the ordinal variable. Okay, so any questions? Or any discussions, any comments? So everyone's clear, right? We only have two data type. One is numerical and the second one is categorical. And that is the most important point to continue. Okay, so we'll go on. Okay, summary measures. So based on these data types, our summary measure different. Okay, so generally speaking, for numerical variable, we use mean, standard deviation, median, IQR, minimum, maximum. Also, I think we should look at this total number and missing number as a part of the summary measures, because most of the time we focus on mean, standard deviation, but these are also very, these also relied on the total number, the missing value. So I think this total and missing values are also important to look at when we do a summary measures. Okay, so I think let's do some iteration. Okay, so do you think we need to explain what is mean and what is standard deviation? Anyone who didn't understand the
Standard deviation?
Yeah, so anyone who didn't understand this terminology, because I'm not going to, spend time on how to calculate means and how to calculate standard deviations.
No, if you can explain about this one, standard deviation, please.
Okay, so okay, let's talk about the quickly talk about the mean and standard deviation, what we mean by that. Okay, and I think let's take a moment here, and then I will come up with the okay, so anyone can see this distribution?
Yes.
Yes.
Okay, so we usually call this a distribution, okay, because usually, so let's take this example. So this example is talking about the intelligence quotient scores, IQ scores, and then try to look at the distribution in the population. Okay. So the indicator mu here is the mean. Okay. So mu is the mean. So it's an expression, a mathematical expression, and sigma is the standard deviation is equal to 15. Okay, so what does it mean? It means that this population has the mean average IQ score of 100 and with one standard deviation of 50. Okay, so when you draw so when you look at the distribution, as soon as you saw this, it is the normal distribution because it is the bell shape. Okay, so if it is the normal distribution, the mean should be at the center. Okay, so like it is written here, the mean is in the center, indicated by the red dotted line. So what standard deviation mean is, let's break down the terminology here. Standard definition. So there are two words in there. Okay. So the first thing you need to know is deviation. So what kind of deviation? So it basically means that deviation from the mean. Okay. So what standard deviations are talking about is how the data are deviated from the mean. So we got a sample. For the sample, we can calculate the mean. And from that mean, we can calculate the standard deviation. So basically, it means that the center of the data, the center means most of the people have IQ scores around 100. So that means that the center of the data is distributed around 100. And then it deviates from the mean, which is deviation. Okay, so how to make it standardized? Okay, so in order to make something standardized, you have to give it a constant. So the constant here is the mean. So every deviation is measured from the mean. So that's why it is called standard deviation. So basically one standard deviation usually measure one standard deviation. So if our data is normal one standard deviation should be 68%. Okay, to be precise, it is 68.2%, which means that 68.2% of the data is distributed around with mean 100 and one standard deviation. So basically it means that if we look at 3 standard deviation, it should include everyone, like up to 99%. Okay, so we call this standard normal distribution. Why we call this standard normal distribution? Because if we make it standardized, we look at from the mean. So it means that within one standard deviation, the data should contain 68%. 2 standard deviation, it should contain 95%, and with 3 standard deviation, it should contain 99.75%. So although this is the very basic concept, inferential statistics come from this mean and standard deviation. And how later we will talk about this when we talk the hypothesis. We are trying to look at the standard normal distribution, the t distribution, and then trying to find our p-value, whether it is significant or not, based on this concept. So everything starts from the basic statistics. So this is the mean and standard deviation. Okay, does it make sense?
Yes, thank you.
So I think we will go on with the okay, so right now we have this is not a complete list of what we can do on a numerical data or even on categorical data. This is just that commonly used statistics we report on publication. So usually we report on mean, standard deviation. Okay, we don't report everything. So we use mean, standard deviation, and median and interquartile range. So we will talk about interquartile range on the next slide. And the minimum and maximum. So it should be clear, right? Minimum should be the lowest value and maximum should be the highest value. But we don't report everything. Okay, and next slide, we will talk about why we don't report everything on the numerical data. So for categorical data, it is straightforward. So frequency mean number, relative frequency mean percentage. So we report number and percentage. We rarely report cumulative percentage. And we talk about total emission value. We'll look at the beginning. Okay, so these are the summary measures, but they are very important for advanced statistics as well. Okay, so we talk about the mean and standard deviation, also median and IQR. So here we have what is called a robust statistics. Okay, robust statistics means these are the measures on which extreme observations have little effect. Let's look at an example. So here we have a data 1, 2, 3, 4, 5, 6. Okay, so these are values. When we find a mean, so the midway between 1 and 6 is the 3.5. And also the median, the midway between these value is 3.5. Okay, so let's quickly do this. 1 is the minimum, 6 is the maximum value. Okay, so interquartile range for around this point, 2.5. So, and the top quartile for around this point, okay, 4.5. But anyway, we will look at the next row. The next row, you can see that we have 1, 2, 3, 4, 5, and 1,000. Okay, so you see the number, drastically changed from 5 to 1,000. So it means that the midway between 1 and 1,000 It's not 3.5. It's larger than 3.5. Although, you know, the only and the biggest one is 1,000. The other one are 1 digit only. So it means that if these are called an extreme value, or sometimes we call it outlier. So if we have outliers are unusual values. So if you have an outlier, you need to check whether this data is correct or not, whether this value is correct or not. So if you have an outlier, it will pull the mean away from the median. So you see the median is still 3.5. So you can see that how the median, how the extreme value cannot affect the median, but it can drastically change the mean value. Okay, so that's why in this case, in the second row, we do not have the normal distribution here. So the first here, we have the normal distribution. So which means that we can use mean and standard deviation in this case. But when we have an outlier or our distribution is not normal. So, okay, again, normal or not normal is what I have shown earlier, the bell-shaped curve. It should be symmetrical. If it is not symmetrical, it is not normal. But we will talk about in our session how we can check the normality. Okay, so right now let's focus on this. If you have extreme value, means your distribution is not normal. Distribution not normal means you don't have a bell-shaped curve. You don't have a symmetry curve. Okay, so if you have the extreme value, you use median and interquartile range. Okay, so if your distribution is normal, then you can use mean and standard deviation, which the distribution is symmetric. Okay, so this is called the robust statistics. Okay, so this matrix, so right now, just listen, okay? I think you will understand more when we do the practical exercise. So this just means that when you have, okay, this one is explanatory variable. It is response variable, okay? So what is response variable? If the outcome or interest that we are interested in, it is the response variable. The exposure status we are interested in, it is the explanatory variable. Okay, so for example, does smoking cause lung cancer? So in that case, smoking is explaining the cause of lung cancer. So that's why smoking is the explanatory variable. Lung cancer is the response variable here. Okay, so what is explanatory variable and what is response variable? It depends on your research question. So based on the research question, they will differ, and that's why in yesterday we talked about the research question, the population and sample. All these are very important to the data analysis. So you cannot just do, you cannot just collect the data and analyze and write a paper. You have to carefully consider what you will put in your study, how you frame your research question, and where will you collect your data. So that is the continuation of yesterday's discussion. Okay, so if you have categorical and categorical variable, and then you can do what is called 2x2 table. And we are talking about this, okay? When you have categorical and another categorical, and you want to see the relationship, you can do a 2x2 table or contingency table. And when you have a categorical variable and numerical variable, you can do a group summary. Okay, So you can do a numerical summary grouped by each category. So say we want to look at the age group by sex. Okay, so you summarize age based on the categorical value, male and female. This is the same here, numerical and categorical. You use group summary. So when you have numerical, you use correlation. Okay. So that is the general idea. And then we will see how we do this in R. Okay, so from this point on, I think everything we will do will be on R. So that's why it is important that you already install R and RStudio. So is there anyone who hasn't done that? Okay, I think everyone has already installed R and RStudio. Okay, so I will quickly change to another screen. Okay, let's see. Can you see the screen here? Okay, so let's go through the R project, okay? Because at this point, what I have done is I just gave you the link to install R and RStudio. So in case you haven't found the website, let's look at the website together, okay? So go to Google and just type R on a search box and then click OK, and then you will see this page, okay? And then the first thing come up is r-project.org. It is the official R website, okay? So click on that, and then you will see this. You will see this page, okay? So this is explaining what is R project for statistical computing. Okay, so to download this, to download R, you just go to the download R, and then you will see this page called CRAN. CRAN is the Comprehensive R Archive Network, okay? So there is the current mirrors. So mirror means these are servers, okay, that host the software R. So you can use the server that is closest to your location, okay? So if you don't want to think about it, just use the default one, okay? Automatically redirection to server worldwide. So just use this one if you don't want to look at it. Otherwise, you can choose the closest server. Okay, so click on this one, and then you will see that 3 different options to download. The first one is for Windows, second one is for MacBook. So someone from the group asked me how to install MacBook. So this is the link to go in there, and then download R for Linux. So I don't think any of you use Linux, so I will skip this. Okay, so this is for R, okay? So download R, click on that, and then you will see this R for Windows page, and then click on the install R for the first time here. And then you click on this one, download R 3.6.3 for Windows. It has 83 megabytes, so it should be quick to download. And okay, so I want to download this. And then this is done with R, downloading R software. So installing R, you just double click on the software and then click next. And then just keep default and then click next and finish it, okay? It's straightforward. So let's move to RStudio. Okay, so this is RStudio website, rstudio.com. Okay, so here, what I want to talk about is there are several products, provided by an art studio. You can see the download page. And then you can see that they have here they showed 4 versions. Art Studio Desktop, this is open source license, and this is free. Of course, we will use this one. And the second one is Art Studio Desktop. So if you are a large corporation or a large institution, and you are doing a lot of basic fundamental works in art, computing, everything, then you should consider this option, commercial license. And this, the second version is called Server, Art Studio Server, which basically, when you install it, your computer will add as the local server, and you can connect online and try to set up the online from your computer. This one is also free, like our free Art Studio Desktop version. And there is a professional version, which is, you can see that is around $5K US every year. So it's highly, priced. So to download our free version, click download, and then you can just download this one for Windows. Okay. For Mac, you can choose the operating system under here. So obviously this is Windows 10.8.7. This is Mac OS 10.13. So here you should know that if your operating system, is less than this will, you cannot install it, or it will behave very differently. And for other operating system, you can install it. Okay, so this is how you download from Art Studio website. Okay, so installation is the same as R, so we will not talk about this. Okay, so I think this downloading and installing is very important. Okay, because I just gave you the link, it doesn't mean that you may change your computer, or you may tell your colleague to install it, and you can ask them to go to our website and download R and Art Studio software. Okay, so this is downloading and installation. So what I will do now is I will open Art Studio. You should follow me the same. Have you finished it? Have you opened Art Studio? So I noticed that some of you use phone or iPad to connect this. So maybe it's a good idea to open your laptop if it is available. Otherwise, you can just follow the webinar here. Okay, so where is my Art Studio? Where is it? Wait a minute. Show window. Okay. Okay, so before I proceed, there is one thing I forgot to tell you at the start. So I believe that everyone got this copy, right? Got a copy of this book, Amstrad 3.2, a definitive guide. Okay, no response. So I believe it is, everyone agree? Okay, so I think you should also open this book, because we will follow this book a little bit today. And then right now I will talk about Art Studio. Okay, here. Okay, so I think right now everyone should have the same, you know, RStudio interface with like this. Does everyone get this?
Yes.
Yes.
Okay. So basically, there is also another, you know, window. So your RStudio should have 4 windows. Okay. So if you don't see the, you know, upper left corner of the window, upper left corner, then you just click here, and then click RScript. So basically, this is called RScript. Okay. In RStudio, you have 4 windows. Okay. The first window, this left upper corner, is called RScript. Okay, it is called RScript. And on the left side, what you have is you have the environment window. Okay, so we will call this environment window. Okay, so this has environment, global environment here. Okay, so don't worry about don't worry about this. Okay, you just remember the name. So the left upper corner we have RScript. The right upper corner we have environment. The left lower corner we have console. Okay, R console. So as soon as you open this, you will see this kind of messages. Okay, our version 3.6.2, something like that. And then there is the prompt. We call it prompt. P-R-O-M-P-T. Okay, prompt. It is basically means that your R is waiting for you to type something here. Okay, so this is called R console. And the last one, the last corner, we have the file environment. So by default, it is pointed to the document. Okay, my document, and for Windows, and also for Mac and Linux, it is also pointed to the default home directory. Okay, so we have 4 windows: RScript, environment window, R console, and then file window. Okay, so this is really important to understand what you call each corner of the window. Okay. Okay, right now, the most important part. Usually, so what I'm talking now is based on my own personal preference. Okay, so I've worked a lot of projects with R. So what I usually find easy is I write the comment here, okay, on RScript, and then see the output on this side. Okay, whatever you see the output, it will be produced on R console. So that's why we want the R console to the right side. You can easily change this using this one, the 4 window pane. It is called workspace panes. Okay, and then you choose console on right. I will click this. Okay, so whatever we type here and we run here, it will appear here. So we can work very easily. We have a larger workspace to look at, but it is, I mean, if you just leave as it is totally fine with it. And then, so I will, starting this point, I will continue using this. Okay, so I think someone raised hand. Zampo, do you have a question? Okay, no response. So let's continue. Okay, so to follow this exercise, what I will do is I will close this. Okay, I will close RStudio, and you also do the same. Okay, and open your Windows Explorer. Okay, so I will show my File Explorer. Okay, so everyone see this one? So what I want you to do is I want you to go to C. Okay, look at this C. And I want to create a folder. Okay, okay, so you can create a folder by right click and then go to new folder. Okay, and then what we will do is we will call this exercise, EACR-CIS exercise underscore SWR. Okay, so we will create a folder and drive C, and then we will give the name exercise underscore SWR. SWR is a short hand for statistics with R. Okay, so the reason I'm doing this is to make everyone on the same page. Okay, so if you mix anything, if you cannot follow it, if you cannot find your R script file, then you should go to this folder and then create a new. Okay. Okay. So we got the folder. We got RStudio setup. So next, what I'm going to do is I'm going to change back to, wait a minute. Change back to the PowerPoint, and I will talk a little bit about the, okay, so we are here. So we have already created this. And then what we will do is we'll create a R script called SWR day one. Okay, SWR underscore day one.R. So how to do that? We will open RStudio again. Okay. Share the screen, RStudio. Okay. So I will close this and let us create a new file. Okay. So go to File, go to New File, and then choose R script. Okay. Again, File, New File, R script. You can do the shortcut key, Control-Shift-N. Okay. So when you get this file, just save it. Okay. Click here, or you can go to File, Save As. Okay. Okay. So right now, you have to go to Drive C, go to the exercise underscore SWR folder, and then give the name SWR day one dot R. Okay, so I will make this large. Can you follow this? Okay, everyone on the same page?
Save file type as all files.
Okay, now let's save this, save it. Okay, so any questions?
questions for now.
Okay, it should be very easy, right? Okay, so you should congratulate yourself. This point, now you are officially working on R and R Studio. Okay. Okay, so the first thing I will talk on using R or R Studio is this one, the shaft key. Okay, it is called shaft. I don't know how to. Okay, anyway, this is called a shaft sign. It just means that these are comments. Okay, these are comments, which means that R will run this line. Okay, so let's try this. There is a run button here, and your cursor is on the same line. So click run. You will see nothing happen. Okay, so you will see the cursor move to the next line, but nothing happen here. Okay, okay, but you will see that this prompt go to the next line. Let's run again. There should be a fourth prompt. Okay, so it means that R is working, but these are the comments, so I just ignore it. So this is useful, okay, useful for giving comments, obviously, and description. Okay, so we can say that, okay, we are learning R and R Studio. Okay, the next thing. So basically what we are doing is we are using R script. Okay, so what we will do is I have explained this. This is the environment. Okay, the environment means this is the space we will be working. Okay, everything we created will come here. Okay, most of the things created will come in this environment. So it is called the workspace. Okay, so what we want to do is clear the workspace. Okay, which is basically this line of comment. Okay, just remember this. RM is basically remove. RM is basically remove. And LS is basically mean list. So essentially what it is we list everything here and then we remove everything here. So that basically means clear our workspace. Okay, because R, whenever you close R, it sometimes automatically save whatever you have done. So when you open in another day, whatever you have working on the previous day will also appear. Like if you ever clean this, there will be a lot of data, a lot of variables here. So when you start a new project, if you haven't done this, then you will you will confuse yourself or even other people. Okay, so it's a good idea to do this at the start. Okay, so this is the basic R startup. Okay, so whatever you're trying to work, this line should be the first line. Okay, so at this point, what we do next is, I think you haven't, if you haven't done it, let's try, let's do this together. Okay, so what we do is we will do two packages. Okay, essentially 3 packages. Okay, the first one would be Haven, the second one would be Margaret R, and the last one would be, of course, Amsterdam. How to install this? How to install any package that is on CRAN. Okay, previously we talked on, I talked about this earlier. CRAM is the official repository. Okay, packages that is on CRAM can be downloaded using this command. Okay, install.packages. Okay, so there is another command called install. This is the past tense. Okay, so that means that what this is to check whether you this is to check the list of packages that are already installed in your computer. So don't confuse the two function. Okay, so the first one we will install Haven. Okay, so the package, you see that this Haven word is embedded between the quotation mark. Okay, these are called quotation mark. That is because it's this is the way install.packages works. Okay, so whatever you want to install, you put that word into the quotation marks and then run this. Okay, so let's try to run this. So to run this, you can select the whole sentence, or you can just click on the same line and then run. So you can see that it is installing, right? So you can see that this it is installing from the web now. Okay, so this means that it is already installed. So you can check this by loading the library Haven. Okay. Or you can just call the library and then Haven. So you can see that there is a Haven package. Okay, so we will not load this. And then we will install .packages, Margaret R, and next we will install .packages, mstacks. Okay, let's try to run this. Okay, so previously we put the cursor on the same line. We put on the same line and then run that line. But right now we will run two lines at the same time. So we will select the two lines and then run. Okay, so these two lines should run one after another. Okay, line by line. So you see it is installing. Okay, so so everything is installed. Okay, so I think